Okay, so let's look at higher degree equations. So first off, degree just means really the exponent. And when we're talking about equations or expressions, and we're saying the degree of the equation or the expression, we're saying what is the highest exponent. So far the highest exponent that we've worked with in equations has been x squared. We've worked with quadratics a lot. In expressions, we did work a little bit with cubics. We factored them. So we've worked a little bit with cubics. But we're going to try to figure out today how to solve some things that have higher than x squared, or higher than x cubed, and see what happens. And we're really only going to figure out how to solve them one way. If they're written in a certain way, they're pretty solvable. If they're written any other way, then we have to do a whole lot more work, and it's beyond the scope of this class. So, let's go back to a quadratic, though. A degree equation we already know how to solve. We know how to solve a quadratic. Say I got something like x squared minus 6x minus 7. And I want to solve it. I know 3 ways to solve this. I could complete the square, I could do quadratic formula, or I could factor. If I can, I want to factor. Factoring wasn't all that hard. Well, hopefully. Start equal to 0, so that's nice. I know my first term is x and x, because that multiplies to give me x squared. And then I'm looking for things that multiply to minus 7 and add to minus 6, so minus 7 and plus 1. Then I say, okay, x equals, I add my 7 over 7 and subtract my 1. So x equals positive 7 and negative 1. I know that. That was awesome and easy. Now let's see something where the highest exponent is larger than squared. So something like x is 6 minus 6x cubed minus 7 equals 0. So everything else looks about the same. And we're going to see if we can solve this by factoring since it worked last time. So let's see, this time I probably already know my last numbers. They're probably going to be minus 7 and plus 1. Those still multiply to minus 7, still add to minus 6. But this time my first term is going to be different. It can't just be x and x anymore. If it's x and x, that's not going to multiply to give me x is 6. Well, there was 2 reasons back here that my first terms are x and x. It multiplied to x is x squared, and it multiplied times my outer and times my inner to add up to that 6x. So, I'm looking for things that multiply to x is 6, and is going to multiply times the numbers to add up to give me that x cubed. So let's try x cubed and x cubed. They both multiply to give me x is 6, and if I FOIL this out, x cubed times x cubed would be x is 6, x cubed times 1 would be 1, x cubed, inner, minus 7 times x cubed would be minus 7, x cubed, minus 7 times 1 would be minus 7. So yeah, they would add up to that minus 6x cubed. So, if I have this equals 0, that means x cubed equals 7, add the 7 over, and x cubed equals negative 1. Well, usually when I'm doing these, I'm not solving for x cubed, I'm usually always solving for x. So, if I have x cubed equals 7 to solve for x, I could just take the cube root. So x equals cube root of 7. Same thing with my other one, I could take the cube root, get x equals cube root of negative 1. Cube root of negative 1 is actually known. Cube root of negative 1 would just be negative 1. Negative 1 times negative 1 times negative 1 would multiply up to negative 1. Okay, so I have these 2 answers. Let's look at my next one. Say I have x to the 10 plus 3x to the 5th minus 40 equals 0. Again, I'm going to see if I can solve it by factoring. This time, instead of, again, having x and x as my first terms, I'm going to use the same idea I did over here and say, well, I needed to multiply to x to the 10. I need to add to that x to the 5th. I need to multiply times those numbers to add, so I had the x to the 5th. Well, if I needed to multiply to x to the 10, though, I can just use x to the 5 and x to the 5. It's kind of going to be a pattern. It's always going to end up being that middle term. If I go to my next one, x is 16 minus 6x to the 8 minus 40, my first term is going to end up being x to the 8, x to the 8. Just try to do these 2 together. So let's see, x to the 5th and x to the 5th, yeah, that's going to multiply to the x to the 10, so that should work. Things that multiply minus 40 add to 3. Let's see, 40 would give me 40 and 1, 20 and 2, 3 doesn't go into it, 10 and 4, 8 and 5. 8 and 5 should work. So plus 8 minus 5. So I'm going to get x to the 5th equals negative 8. And x to the 5th equals 5. So let's see. Again, I don't want to solve for x to the 5th. I want to solve for x. So I'm going to do the 5th root. If it was x squared, I would do the square root. X cubed, I'd do the cube root as we did before. This one I'm going to do the 5th root. And I don't know the 5th root of x to the 8. And I don't know the 5th root of 5. I'm sorry, negative 8, not x to the 8. I don't know the 5th root of negative 8. I don't know the 5th root of 5. So I just have to leave it. Okay. Do the next one. We already had the numbers written out. This time it looks like 10 and 4 are going to work. So minus 10 plus 4, which means x to the 8 is going to equal 10. And x to the 8 is going to equal negative 4. Okay, so let's go ahead, take a second. What root? It's going to be the 8th root. So take the 8th root. So I'm going to get the 8th root of 10 and the 8th root of negative 4. Sure, it gets a little tricky. So hopefully you all remember that when I had square roots, and if I was taking the square root, like if I had something say x squared equals 4, and I was taking the square root of both sides, and I got x equal to 4, this is where I threw in a plus or minus. And I threw in that plus or minus because if I squared a positive, I got a positive. If I squared a negative, I got a positive. So both of them were true. Whenever I'm taking an even root, that is true. So whenever I'm taking an even root, I need a plus or minus in front of it. We can think about it real quick. So say I have something like negative 1. And I have negative 1 to the first power is negative. So this would be negative 1 to the first power. If I have negative 1 to the second power, that would be a positive 1. If I have negative 1 to the third power, that would be a negative 1. Negative 1 times negative 1 times negative 1, we did it up there. Negative 1 to the fourth power, I times it by another negative 1, I'd get 1. Negative 1 to the fifth power, times it by another negative 1, get negative 1. So basically, whenever I have an even number, even root, even exponent, I always have a positive, meaning when I take a root, I always have to account for the plus and the minus, because the plus to that power would give me a positive, and the minus to that power would give me a positive. It also means I can't take an even root of a negative number. Remember with square roots, square root of a negative number was imaginary. I can't take an even root of a negative number. Odd roots, I can. Cube root of negative 1 would just be negative 1. Fifth root of negative 1 would just be negative 1. Odd roots, everything just stays exactly how it is. I don't have to add plus or minuses in. I can have negatives, it's fine. Even roots are the only ones that I have to add a plus or minus in front of, and I can't have a negative underneath the radical. Okay, let's try another one. Say I have 2x to the 8 plus 5x to the 4 plus 3 equals 0. So again, I'm going to go ahead and factor. This time I do have a number in front of, so do whatever method you do to factor these. If it's multiply the first coefficient times the constant or whatever, factor it however normal. Just make sure that it's x to the 4 and x to the 4. So let's see, I'm going to end up with 2x to the 4 plus 3 and x to the 4 plus 1. You can always FOIL it out to check if you want to. I'm pretty confident in myself. So I'm going to get x to the 4 equals negative 3 over 2. And I'm going to get x to the 4 equals negative 1. Take the fourth root of both sides, so x equals fourth root of negative 3 over 2 and fourth root of negative 1. I could remember to add the plus or minus in here, but since I can't really have a fourth root of a negative number anyways, really I just have no solution. Okay, so let's try the last one. Say I have 6x minus 7 square roots of x plus 2 equals 0. Again, I'm going to try this by factoring. So this time, instead of having x or x to the 4 or x to the 8, I'm going to use the square root of x as my first term. Square root of x times square root of x is going to give me that x, so it will work. Okay, so let's see. What would this factor to? I would do 2 square roots of x there, 2 there. So 2 square roots of x plus 1, 3 square roots of x. Oh shoot, minus on both sides. Sorry about that. 2 square roots of x minus 1, 3 square roots of x minus 2 equals 0. So 2 square roots of x equals 1, square root of x equals 1/2. And 3 square roots of x equals 2, so square root of x also equals 2/3. Solve for x. This time I'm not going to take a root, I'm just going to square both sides. So I'm going to get x to equal 1/4 and 4/9. And that's it. You can check it to make sure, but it should work.